Welcome to Maths with EJD. In this video, I want to start a series on statistics and see how far we can go talking about everything statistics. Come along in this journey. Be sure to subscribe to the channel so you don't miss any of the things we're learning here. Of course, you want to hit the notification bell so you can always get alerted when a new video is released. And also, don't forget to comment, like, and share. So let's get to the lesson on statistics. So the first thing I want to talk about will be um, okay, well, I think it's very important to even try to know what exactly statistics is about. I think that's the natural place to start from. So we're probably used to this whole idea of, working with data, analyzing data, and things like that. But, some things are so close that we don't actually know how to define them, right? So I think this is important. So, what is the definition of statistics? So, straight to the point, definition. So, we can simply say that statistics, statistics is the practice, is a practice or science of collecting, analyzing, interpreting, and presenting. Well, I mean, maybe this can be debated, collecting numerical data in large quantities. Of course, just like there's hardly a perfect definition for anything. So, but this we can work with this, right? So, statistics is the practice or science of collecting, analyzing, interpreting, and presenting numerical data in large quantities. So, um, we can say that it is used to infer proportions, in a whole form, in a whole from those in a, it is used to infer proportions in a whole from those in a representative sample. Okay. So depending on the source you're looking at, you can have maybe some variations in this definition. So that's very good. That's a very good starting point, talking about the definition. So can we talk about the types of statistics? Types of statistics. Okay. Statistics is broadly classified into into two into two major types. Okay. First, you have what you call descriptive statistics. Descriptive statistics. So this will be statistics that describe the data you have, so to speak. So this actually focuses on summarizing, summarizing and organizing organizing data to describe its main features. So it uses like tools like what you call the measures of central tendency. And the measures of central tendency include, so I mean, we're going to talk about that in depth. So it's actually using one value to estimate the whole data you have. So measures of central tendency will be things like mean, median, and mode, which are relatively well known. Mean, median, and mode. So we're going to talk about this in depth, but for now, let's just uh, make do with the information. Then the next thing is we have measures of dispersion. So as the name implies, it means that you're talking about how dispersed the data is from the measures of central tendency. So you have a mean, right? Then you're now looking at other things that measure how far apart some data are from the mean and things like that. So you're going to see all this. So you have measures of dispersion, and they include things like range. Range is simply the difference between the lowest data value and the highest data value. Then from there, you talk about variance. Of course, that also deals with deviation. So, in fact, yeah, you have range, you have deviation, because deviation is what leads to something like variance. And then we now get to compute standard deviation. We're going to do all of this as we progress in the course. Okay. Then you also have I think that we have measure of central tendency, measure of dispersion. Okay. And then, well, we can also talk about things like graphical representations. Graphical representations. So when you use graphical representations, you can now have things like histograms, histograms, bar charts, bar charts, pie charts. I think there's still one more measure that we'll get to see along the line. Things like skewness, kurtosis, and all of that. We're going to see that as we go on later. Okay, so a very good example of descriptive statistics would be something like this. Say summarizing, summarizing a class's a class's exam scores, a class's exam scores by calculating calculating the average and visualizing them on a bar chart. Imagine that a class of 50 students write an exam. So if you want to use for this, you can use like a measure of central tendency, like the mean, to say, okay, the average score in this exam is this. So, I mean, let's say the average score in this exam is, say, 55. That means that if you sum up all the scores obtained by all the students and divide by 50, you get 55. So that doesn't mean that there's definitely someone there who got way above 55. Maybe someone has 90, somebody has 11, and things like that. So, but then that central measure, gives you an idea of the performance of the students. Then if you want to get clearer picture, then you can begin to talk about measures of dispersion, like what is the standard deviation, what is the variance, and things like that. So, but we are good. That's what we are in for in this course. So let's go gradually. So the next thing would be about the second type of statistics, which will be inferential statistics. Inferential statistics. The idea of inferential statistics is simply you drawing inference from from the data you have. So that's why it involves making predictions, making predictions. So that's the idea of drawing inference, making predictions, or what you call inferences about a population based on data collected from a sample, data collected from a sample. Okay, so we're going to see all of this in depth. So this inferential statistics includes things like It includes things like estimation. Okay. Estimation. For instance, you can do something like estimating a population parameter. Estimating a population parameter from the data you have. In fact, I get to do this a lot because I'm a mathematical biologist. So I have mathematical models, but then we have to use data to fit our model to data to actually get some parameter values. Then, of course, another aspect of inferential statistics is a very popular one too, which is hypothesis testing. So you make you make, what is it called now? You make a guess and you try to test if it is correct or not, or more like making a claim and testing if it is correct or not. So, for instance, you can just say that, oh, girls perform better than boys, and then you go to the field, collect data, and you want to see based on the data you have if it is validated. But of course, there are other issues like if the data you're collecting, if it is representative of the population you're interested in, and things like that. So that is what these are the kind of things we'll be talking about here. So testing claims. So testing claims about about a population mean, about a population mean or proportion. So that is hypothesis testing. Okay. Okay. So let's give a kind of simple example. So imagine estimating the average weight, estimating the average weight of all adults, of all adults in a city by surveying a sample, a sample of 500 adults. Okay. That is a good example of estimating, for instance. Okay. So with that, we've come to the end of something like introduction to statistics, right? So let's talk about yeah, like okay, the whole thing we're doing is introduction to statistics. So let's look at another part, which is about which is about basic concepts. Basic concepts. Of course, some of the concepts I've mentioned before now in the previous part, but let's zoom in on this right now. Basic concepts in statistics. So one important concept in statistics you always come across is the idea of population. Population, okay? So this is actually the entire group of individuals, the entire group of individuals or data points that you are interested in, that you are interested in, that you're interested in studying. That is your population. Okay. So a very good example may be, say, all students in a school may be your population. All students in a school, or you may want to talk about all students in junior high school or all students in senior high school. So it all depends on your aim. Okay. So we talk about population as a basic concept. So the next thing is that is closely related to population is the idea of sample. Okay. Yeah, sample. So a sample is simply a subset, it's a subset of the population, it's a subset of the population that is used for analysis, that is used for analysis. Sometimes you may have, for instance, if you want to find out the behavior performance of students across different regions in Nigeria, for instance, Nigeria has 6 geographical regions, right? And of course, it may be, in fact, impossible for you to get data on every student in each of the regions. So you may now find a way of taking samples to represent the whole region. So of course, there are very nice ways of doing that, which we are going to find out as we move on. to do that so that you can be sure what you're getting, the data you're getting, the sample you're getting is actually representative of the population so that you can get some reliable results. So a sample is a subset of the population that is used for analysis. For instance, we can say that a group of 50 students, a group of 50 students selected from the entire school, from the entire school for a study. So the population is the entire school, but a sample of that population will be maybe some 50 students randomly selected or selected based on certain well-defined criteria. That can be your sample. Then apart from sample, we have what we call parameter. Parameter. So it's actually a numerical value that describes a characteristic of the population. That is your parameter. So a very common example would be what it would be the population mean. Okay, the population mean. Okay, and then you have statistic. We are going to come across all of these things a lot. Especially when you come to inferential statistics, you're going to be talking about statistic a lot. Statistic. So a statistic is also a numerical value. It's a numerical value, but it's a numerical value that describes a characteristic, a characteristic of a sample, e.g., sample mean. So a numerical value associated with the population is called a parameter, while a numerical value associated with the sample you take from the population is called a statistic. So parameter and statistic are the same, except that parameter is to population and statistic is to sample. Very important to take note. So let's see uh, concept of data and its types. Concept of data and its types. So what is data all about and what are the types of data? So first off, uh, data data are raw facts and figures, raw facts and figures that are collected for analysis. So, one very important thing one thing that has stuck with me about data, is that, we used to contrast it with information, which we are going to look at down the line, though, that data is unprocessed information, while information is processed data, so we have all of that. So that's stuck with me since maybe from secondary school or high school. So data are raw facts and figures that are collected for analysis, and data can be classified. Data can be classified into two major types. You have the first one, it can be qualitative. You can have qualitative. In fact, let me put it this way. You can have qualitative or what you call categorical data. Categorical data. Okay. So data can be qualitative or categorical. In that case, you have this to be non-numeric. This is non-numeric data that represents categories or groups. So that's why it's called categorical. It represents categories or groups. So a nice example would be gender, okay? Gender, that's male or female, okay? Another example would be, say, car brands. Car brands, say Toyota or Ford. So those are categories. Okay. They are not numerical, but they are just like they are some kind of classification, so to speak. So it's that categorical data are said to be qualitative. And then we have quantitative, quantitative, or what you can call numerical data. So data can be quantitative or numerical too. In this case, um, so quantitative or numerical data is actually data that represents data that represents quantities, quantities, and can be measured and can be measured. Okay, can be measured. So example would be age, because age it can be measured in years, in months, in whatever you choose. So someone can be 2 years old, someone can be 20 years old, someone can be 75 years old. So those are quantitative or numerical data. Quantitative or numerical data. So you can also talk about height. So height can be measured in meters, or if you're in the US, that's feet, right? So age in years, height in meters, or you can also talk about your salary. It's numerical, right? So it can be in naira, in dollars, in yen, or whatever. So those are actually quantitative or numerical data. Quantitative or numerical data. Okay, so so that's the concept of data and types of data. Now we move on to talk about differences. I started talking about this previously, comparing and contrasting data and information. So differences between data and information. So if you look at the core idea of statistics, right, you're gathering data, you're analyzing it, and then you're interpreting it. And when you interpret it, right, you're drawing information from it. So the interpretation is to help you draw information from it and probably to now make decisions based on that. Okay. So if we start with the idea of data, data is like you saw before, it's actually raw, unorganized. It's raw, unorganized facts that need to be processed, that need to be processed. Okay. It may, it may or not have meaning. It may or not have meaning until analyzed. Until analyzed. Okay, for instance, I get to do some machine learning stuff, right? So some data, once you see them, you don't know what to make of them until you begin to, try to, get some information from them. And that's why for a data scientist like me or a machine learning enthusiast, so to speak, um, one of the first things you want to do with the data you have is you want to do what is called exploratory data analysis. So you want to start checking out the data. Okay, what are we want to get the descriptive statistics on the data. What is the mean? What is the standard deviation and things like that. And those are the kind of things you get to do as a data analyst or data scientist or a machine learning person, right? So most times data may not have any meaning until you analyze it. Okay. Or one of the easiest ways to draw meaning from data is to maybe put it on a graph, like put it on a bar chart or pie chart or something. So though it's still raw, but in fact, by the time you put it into picture format like that, you can easily already start getting ideas. That's why in exploratory data analysis, we use visualization as a way of starting to get information like that. Okay, so let's talk about example of data. Okay. Say scores, you have of 10 students, scores of 10 students in a test. Okay, that's data. So you have 85, 92, 78, 67, 81, 95. That's 1, 2, 3, 4, 5, 6. Then maybe you have 77, uh, 82, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Maybe you now have 54 and maybe say 62. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I mean this is raw data. You in fact, if you're not told that it is a score of 10 students, you may not even know what it is about. So I mean, then, but even by the time you're told it is the score of 10 students, then you'll be wondering, okay, you can already begin to think. Once you start thinking about it, in fact, you've started processing it, you're already thinking, okay, who scored the highest? You're already getting information from that data. You're already processing it, even without doing even without touching a pen, you're already processing it like that. Oh, the highest score is 95. That is actually the maximum score, which is also which is an information about the data, right? Which is like an idea that you're getting from the data. Okay. So scores of 10 students in a test, like all these things I've given, right, is actually raw data. And just like I said, once you start thinking about it, you have started processing it. Okay. So that's data. Then let's talk about information. Information. So for information, right, it's actually data that has been processed, data that has been processed and organized in a meaningful way, providing, providing insight or context, providing insights or context. Okay. So, and just like I said the other time, data, you can look at it like data is unprocessed information, while information is processed data. Of course, that may be some kind of layman definition, but it gives you an idea of what we're talking about. Okay. So, an example of information would be calculating the average, calculating the average score, the average score from the test scores. So once you calculate the average of the test scores you have there, then you can say you have that's an information about the performance of the 10 students. Calculating the average score from the test scores to determine class for performance, to determine class performance. For instance, let's assume that you have an award for the best class and you want to award it at class level, not at individual student level. So you can just find the average of their test scores and then you say, okay, this class with a higher average score or the highest average score gets the prize, That's one way to look at that. Okay. So let's talk about forms of data. Forms of data. Forms of data. Okay. We've talked about types of data, which can either be qualitative or categorical, which can be qualitative or categorical or quantitative and numerical, right? Those are some things. We have seen those types now. Um, okay. So let's talk about forms of data. Talking about the forms of data now, we have two types again. We have discrete data. I thought I have a whole playlist on probability, which you can check out. And then we get to talk about discrete data and continuous data a lot. And you can see that, interestingly, probability is some kind of subset of statistics. But interestingly, I've taught that part. So when I get to the probability part of this course, I'm not going to talk about it because I'll just refer you to the videos because everything blends together. So talking about discrete data now. So this is actually discrete data will be countable values, data that are countable. So data with countable values, and they are often whole numbers. In fact, if not almost always whole numbers, they're often whole numbers. Okay. So for instance, if you're talking about the number of if you have 10 families in a place and you want to know the number of their children, that is discrete data. Okay, because you can say, okay, the first family has 3 children, the second one has two, the third one has three, and so on and so forth. So discrete data with countable values, and they're often whole numbers. Or the number of students in a class will be discrete, right? You can't have like half a student. You can't say you have 50.5 students. No. You can have 50 students, you can have 49, you can have 33, and things like that. So discrete data talks about countable values that are often whole numbers. And a very good example would be the number of books on a shelf. The number of books on a shelf. The number of teachers in a school. Okay. The number of students in a class. The number of books in a student's bag. All those are discrete data. Okay. So, and then apart from discrete, you have what you call continuous data. Continuous data. Okay. So for continuous data, you're talking about data that take, data that can take actually, that can take any value within a given range, within a given range. Okay. A very good example of continuous data will be things like height and weight. So, for instance, to be hard to say someone's height is 165 meters precisely. Okay, you can only estimate to say 165. But if you look at it, the person can be like 159.7 or 160, 164.9 or 165.3 and things like that. So data that can take any value within a given range is called continuous data. So things like weight, height, and all that. So example, the weight of a person, the weight of a person. So it can be whole numbers and it may not be. E.g., you have 60.5 kg, 75.2 kg. Even when you have, say, even if you have 54.0 kg, it is still continuous, right? Because it can take decimal. So with this, I've come to the end of this first video on introduction to statistics, and it's been such a nice ride. You surely don't want to miss the other videos in this series. So you want to subscribe to my channel and hit the notification bell so you can always get alerted when a new video is released. Also, comment, like, and share so that we can always keep learning together. So watch out for the next video, which will be on measurement scale in statistics. Until then, see you. Bye.